Hi, everybody. It is hopefully Tuesday if you're viewing this recording, unless you're working ahead. And today's lesson is basically to go over some common mistakes that I've seen over the years as I've taught this sort of lesson, this kind of just working with proportions in general. Just to kind of get you now to that point where you kind of perfect the process. We've kind of got the routine down. There is some opportunity to kind of confuse some of the different rules that we have. So I'm going to show you some examples of problems where there's some common errors, and those are the type of problems that we're going to look at in today's quiz. Okay, so here we have two triangles. Notice that I do have some parallel lines here. And the first thing we're going to do is we're going to look at this, and we're going to show why these first, ABC, is similar to these two triangles are similar. And we're going to get our similarity statement written down. So first of all, looking at this, notice that I have parallel lines. So how do I know that these are similar? So think about that. If you want to pause this for a second before you hear the answer, that's fine. The reason that we know that they're parallel is because of angle. Remember, if we have two angles, we know all three would be congruent, and congruent angles makes these triangles similar. So let's look at that magic Z that we talked about back when we had parallel lines. If the top and bottom of the Z are parallel, then these angles of the Z are going to be congruent. Now, I also know that I have vertical angles. So there's two of my angles right there. And so that's how I can be sure that these are similar, just by looking at the parallel lines. Now, let's write our similarity statement. And this is where a lot of people make a mistake. And this is we don't always write down our similarity statement. To write down our similarity statement, I'm going to start with the angles that I know are congruent. So since I marked B as congruent to E, I'm going to start my similarity statement with those letters. You don't have to. You can find a different pair that are congruent. That's fine. That's just how I chose to do it. If you wanted to start with A and D, that would be fine. Now I'm going to move to the second angle I have marked, and that is C. Now notice how I'm putting it in the second spot on both of them. Congruent angles should be marked in the same spot when you name your similarity. And then last I have angle A matching up with angle D. So now I have a similarity statement that is written in the correct order. Notice that I could have also written A, B, C, and D, E, C, as long as the corresponding angles are in the same spot in both triangles. Now I'm ready to set up my ratio. So I know that I have to find X, okay? And so I'm going to look and find which piece corresponds to X. So I'm going to go here and see how that is segment CD. So I'm going to highlight those right there. There's CD. So I know that it's going to match up with AC because it's in the second two spots there. This is where most people make a mistake. Those are across from each other. So when you set up this problem, did you match the 10 and the X? Most people accidentally would have matched the 12 and the X. So make sure that you're picking the right pieces. Okay, so if you did this wrong, pause it now and redo the problem. Otherwise, if you have them set up that way, you can keep going and watching the solution, see if you got the same thing. Now I know that BC matches up with EC. I'm going from larger to smaller triangles, staying consistent, so I'm going to put the 12 over the 3.2. And now I have a proportion to solve, just like we did over and over and over again in so many of the problems. 10 times the 3.2 is equal to 12x. And then I'm going to divide both sides by 12. Get x alone. So your final answer should have been 2.6 repeating. Now I'm going to check my answer and make sure that it is a reasonable answer. Okay, so over here for this x I got 2.6 repeating. Looking at my triangles now, you see how this one relates to the shorter of the two, and it is shorter than the 3.2, so I feel pretty confident that I'm on the right track. So the most missed problem that looks like this is because people just want to line them up on the same side. But you can see that this is a dilation, and this is my center of dilation. Remember what happened when something got dilated to the other side of the center of dilation? It got kind of flipped around, didn't it? Okay, this side moved to this side moved to this side. So it kind of makes sense if you think about when we did our center of dilations here at this point, that things jump to the opposite side. They get flipped, and that's why its corresponding side is on the flip side there. Okay, so that was the first one I wanted to show you. Now let's look at the second problem here. I'll give you some numbers to play around with. Let's say that you have something like this. I have triangle ABC, and here's a line parallel to the base of that. And I'll give you some segments here. I'll say this is 12. This piece right here is 8. And this piece is 10. And I want you to find AB. Go ahead and pause the recording now and go ahead and find AB. Once you have an answer, go ahead and turn this on and you'll see how it's done. Okay, most people that make a mistake with this, they see this triangle and they immediately want to do side splitting. Okay, they want to say, all right, well, 12 over that is 8 over 10. They just want to use the numbers in the picture. But what you have to realize is these are not the split sides. Okay, those are the bases. So I can't use those in the side splitting theorem. For this one, we're going to use the similar triangle. This triangle right here, the yellow triangle, will be similar to the big triangle around the outside. My blue triangle. You're actually using similar triangles for this one. Because you don't have the splits on both sides, you're actually using the similar triangle. So if I take the side of the smaller, or the 8, it corresponds to the 10. And this side over here, the smaller, the side of the yellow is 12, and it would correspond to the AB. Okay, so 10 times 12 would equal 8 times that AB. Okay, so if I want to find AB, I just divide both sides by 8, just like when I had an X there. And I get AB is 15. Okay, so be very careful that when you're looking at a problem like this, determining whether you have the side splitting or you have, in this case, you're using the similar triangles. So let's do another one similar to this. I'm going to give you some different numbers. Get the right colors in here. The same picture. I'm going to change it up a little bit on you this time. And all I'm going to ask you is to tell me which theorem are you going to use, side splitting or the similar triangles. We're not actually even going to solve these. I'm just going to show you where you have the numbers. Then we're going to solve one more. Okay, let's say that I know that this is 2, I'll make it 12, that's 8, and this whole thing over here is 15, and you want to find this piece down here. Okay, which approach do you think you're going to use? Are you going to use the side splitting, or are you using similar triangles? Now see how I have my sides, the pieces are both on the sides? That is the side splitting. Be very careful though, because you're going to do x over 15, the lower part over 15, so over here would equal 8 over 20. Okay, and where did that 20 come from? Well, if I'm going to use 15 over there, which is the whole thing, I have to add that 8 and 20 together, 8 and 12 together. Okay, so that's the side splitting. Okay, let's look at another one. What if, using the same picture here, I have something like this. Okay, which one am I going to use? If you need time to think anytime in these videos, just pause them and think about it. Okay, notice how this time I don't have the side splitting, I have these bases. I'm going to use my similar triangles in that case. Okay, so I'm going to use this triangle ABC similar to triangle ADE. Now let's go ahead and do this one. Pause the recording, try to do this one. We are going to find well, let me give you some different numbers. I'm going to make this one 20. This is 16. We want to find this piece right here, DB, and I'm going to make this one 18. Now this one's a little tougher. Go ahead and pause the recording. See if you can find the length of BD, and then I'll show you the solution. Okay, since I have the bottoms again, I am definitely looking at similar triangles. So let's start with this triangle right here. The 20 corresponds to the 20 plus x. Okay, or if I don't want to do it that way, I can say it corresponds to this piece right here along the bigger triangle, which is just AB. And what I'm going to do is I'm going to find AB and then subtract the 20 to get what's left right here. Okay, so I don't have to set my equation up with x. I can find some other piece that helps me find x. That ratio is going to equal the ratio of 16 to 18 because that's the bottom of my triangles. Let me show you this to you real quick using my highlighter. Now see how the smaller triangle there is yellow. The other triangle that I'm comparing it to is this pink one. Now I'm going to pull these triangles down here so you see them separately. Okay? So if you think about it, if I write the actual lengths on here, this was 20 and this was 16. This was 18 and this is AB that I'm going to find. I know that part of AB is 20, but I'm going to find the whole thing. So that's where I got the 20 over AB is equal to 16 over 18. Okay, so now I get 20 times 18, which is 360, is equal to 16 times AB. So you know the routine, we divide by that 16. I like to get everything canceled out and put it all in my calculator in one nice swoop here, so I can just put in 20 times the 18 divided by the 16. And some of you guys have this pattern down to those of you that participate every day in class, well, you have this down. So now I know that this whole piece, this AB that's up here, When I look on my calculator here, it says it's 22.5. So the piece that I'm looking for is what's left over out of after that 20. So subtract the 20 from that, and I get 2.5 for this piece right here. Okay? So x is equal to 2.5. Okay, so hopefully you see some of these more complicated problems, although sometimes we will find a piece, the same routine, you have to think about what you're looking for, and sometimes we have to subtract to get what we're looking for. Sometimes we have to add things together to get corresponding parts. So those are the type of problems I wanted to show today. I wanted to show something that's starting to get a little more complicated, something that you have to piece some other steps together to get it to work. So what you're going to do now, you are going to go down, and this is the second day. So we are on the 3.10 B. So now you're going to take a quiz. It's going to have similar problems like what I've covered here. Make sure you can set them up correctly and get the missing piece. Make sure you look for what we're looking for when you solve these.